Welcome to Networks Professionals.
Welcome to today's Explainer. We're jumping right in today because if you've ever managed a network or if you're hitting the books studying to do so, you already know that security and traffic management aren't just important, they're absolutely paramount. Today, we're demystifying extended access control lists, or ACLs. I want you to think of an extended ACL as the ultimate highly trained VIP bouncer for your network's exclusive club. This bouncer doesn't just casually check if you have an ID. They check exactly who you are, who you're trying to talk to, and specifically what kind of conversation you plan on having. We are going to break down exactly how this gatekeeper works, pulling directly from our source material. Here is our roadmap for mastering these essential network security fundamentals today. We've got 5 quick stops. 1. Meet the VIP bouncer. 2. The ultimate filtering criteria. 3. Deciphering the command syntax. 4. Real-world ACL examples. And 5. Crucial rules for success. Let's get into it. Part 1. Meet the VIP bouncer. Let's formally introduce you to extended ACLs. All right, so what exactly is an extended access control list? Basically, these are highly granular network traffic filters. And honestly, that word granular is everything here. We aren't doing some broad, sloppy sweep. We are doing a microscopic inspection. The bouncer is constantly evaluating a specific combination of things: the source IP address, the destination IP address, the exact protocols being used, and the specific port numbers. This is what allows you to securely restrict specific services. For instance, you could use an extended ACL to let web traffic flow completely freely while slamming the door shut on remote management traffic coming across that exact same connection. It gives you incredible, pinpoint control over your environment. Okay, let's dive into this comparison for a second, because it's vital to understand why extended ACLs are the superior choice for complex security tasks. Think about a standard ACL. It's pretty basic, right? It only looks at the source IP address. It essentially just looks at a packet and asks, where did you come from, and makes a permit or deny decision based strictly on that one fact. But the extended ACL, it evaluates the source, the destination, the protocol, and the port. It's asking, where did you come from, exactly who inside are you going to see, what language are you speaking, and which specific door are you trying to use. It is a massive, massive upgrade in security capability. Moving right along to part 2, the ultimate filtering criteria. Let's look at the exact who, what, and where our bouncer is checking. There are 3 core capabilities of extended ACLs you need to know. First up, source and destination. You can specify exactly who is sending the packet and where it's intended to go. Now, this can be an individual host, an entire subnet, or just the word any if you want to cast a wide net. Second, protocol and ports. This is where we filter based on layer 4 protocols like TCP or UDP. We can target exact ports like port 80 for HTTP web traffic, or we can use operators, things like EQ for equal to, GT for greater than, or LT for less than. And third, placement. This is a huge design point. To save your precious network bandwidth, extended ACLs are best placed as close to the source of the traffic as possible. You really want to drop that unwanted traffic before it clogs up your entire network infrastructure. Section 3. Deciphering the command syntax. This is where you, the network boss, actually write the guest list. What's really interesting here is how we can take that dense, intimidating Cisco iOS configuration syntax and map it out into simple building blocks. So if you're creating a numbered extended ACL, you have to use a specific number range. That's typically 100 to 199, or the expanded range of 2000 to 2699. Using a number from those ranges instantly tells the router, hey, heads up, expect an extended ACL. Then you've got your protocol options: IP, TCP, UDP, or ICMP. Finally, your operators. Instead of just matching a port exactly, you can use EQ for equal, NEQ for not equal, LT for less than, or GT for greater than. These operators are your tools for crafting ultra-precise rules. Let's walk through the actual formula from left to right. First, you declare access list, followed by your chosen number. Next, what's the action? Is this a permit or a deny statement? Then you name your protocol. After that, you define the source, right, followed by the destination, and finally, if it applies to your rule, you define the port operator and the port number itself. It actually flows with a very strict, logical sequence. Once you memorize this rhythm, reading and writing these ACLs becomes absolute second nature. And that brilliantly illustrates our next section, Section 4, Real-World ACL Examples. Let's see this bouncer in action. Okay, here's a perfect real-world scenario from our source material.
blocking telnet to a specific server. Let's literally translate the syntax into an English sentence. Access list 100. We're creating an extended ACL. Deny TCP. We're dropping TCP traffic. Any. The source can be literally anyone on the planet. Host 192.168.1.50. The destination is exactly this one specific server. EQ23, but only if the destination port is exactly 23, which is the port for telnet. So this single line explicitly blocks remote management via telnet to this specific server, while leaving all other traffic completely alone. Pretty cool, right?
Now let's flip it and look at allowing traffic. Here we want to allow web traffic HTTP from a specific subnet to a specific server. We start with access list 101 permit TCP. That means we are explicitly allowing TCP traffic. Next is our source subnet, 10.0.0.0, followed by its wildcard mask of 0.0.0.255, which just specifies the exact range of allowed IPs. It's heading to the destination host 203.0.113.10. And finally, EQ80, meaning port 80 for HTTP. Basically, we are telling our bouncer, hey, if an HTTP web request comes from this specific group of people and it's going to this specific web server, let it walk right through the front door. We are now at our final section, Section 5, Crucial Rules for Success. Now, I'm going to purposely slow down the pace here for a minute, because these unbreakable rules are where literally everyone makes their mistakes. These are the most common pitfalls when you're learning this stuff. There are 3 unshakable laws of ACLs that you must remember. They are sequential processing, the implicit deny, and directionality. If you forget even one of these, your VIP bouncer is going to fail at their job, and your network traffic will absolutely not behave the way you expect it to. Let's take the first rule, sequential processing. This simply means rules are checked top-down. The essential takeaway here is that the bouncer reads your list strictly from the top to the bottom. The very first match it finds determines if that traffic gets permitted or denied. And here's the kicker. Once a match is made, the bouncer stops reading the list entirely. If you have a broad deny everything rule sitting at the very top and a super specific permit web traffic rule at the bottom, that web traffic is getting denied because the router never even looks at the bottom rule. The order matters immensely. Next is my absolute favorite, the invisible deny. At the end of every single ACL you write, there is a completely invisible statement that reads, deny IP any. You don't type it, you won't see it in your configuration file, but I promise you it is there. It is the silent killer of newbie connectivity. It basically means that any traffic not explicitly permitted by you is going to be blocked. To stick with our club analogy, if your name isn't explicitly written on the bouncer's guest list, you don't get in, period. Finally, we've got directionality. Listen, you can write the most perfect, secure, logically flawless lists in the world, but it isn't enough. Once defined, that ACL must actually be applied to an interface. You do this using the IP access group command, and crucially, you have to specify either in or out. You have to tell the bouncer which specific door to stand at. Are they checking traffic as it comes inbound into the router interface, or as it's trying to exit outbound from the interface? Because an unapplied ACL is just a useless piece of paper sitting on a clipboard. So we've covered the capabilities, the syntax, and the unbreakable rules straight from our source text, which brings us to the ultimate question for you. Now that you understand exactly how to securely restrict services using these granular criteria, will you start by drafting custom extended ACL rules tailored to your specific devices, or will you first map out where you need to apply them inbound versus outbound on your network interfaces? The power to secure the network is in your hands now. Thank you so much for joining me on this explainer, and happy configuring.
Thanks for watching.